Let's break down the path to becoming a software developer. I will first start with an intuitive example to explain what programming is. Then we'll briefly talk about how a computer works. Once you grasp the basics, I will discuss how much time it takes to be a developer and why programming is hard or why people pay them a lot. And lastly, I will give you an actionable step-by-step guide for starting to code. Let's consider a cook who gives a cake recipe. Add some egg, mix with flour. What actually happened is you're programmed. If you follow the recipe precisely, you will get a delicious cake. However, there are ambiguities in each step. You, as a human being, feel those missing pieces. Nobody needs you to say that to put some flour first, you need to open the flour container. Programmers are not that lucky as cooks. We need to feel every step, meaning each and every step should be ambiguity-free. A computer is just like a human being trying to make a cake, always in the process of following some recipe, which is called software. You, as a programmer, create new recipes. If you ever went out of a recipe and created your own flavor, you are a good programmer candidate. Let's see how computers work. Are you familiar with marble machines? Let's first see one. And here is one capable of addition.
If we now add 1 to it, it now goes to the state of 1. If a 1 is added to another 1, it must carry to the 2-bit and clear the 1-bit. This is accomplished by the rocker rocking once again to the left and dropping the 1 marble, which now is cleared.
Smart for just marble and wood, right? Computers are just like a marble machine, but use electricity instead of marble balls. How can a ball be equivalent to electricity? Think like this. If there is a ball, then the machine works. With the same logic, computers simulate ball existence with the existence of electricity. This is where the 1 and 0 come from. If there is electricity, meaning ball exists, we have 1. If not, we have 0. Both 1 and 0 are meaningful. It is also called bit. And those rockers or levers that you see in marble machine are called transistors in computer world. A typical processor has about 4 billion of those transistors. Pretty complex, huh? Let's dive into a tiny example. Suppose we want to represent numbers in the computer, but we only have 1 and 0. How should we represent 2 or 3? Let's ponder a little. We only have 1 and 0 and we want something bigger than them. It is kind of similar to this problem. We have a different symbol for each number, 0 to 9. But sometimes we want to represent 10. We didn't invent a new symbol for 10. We just put 1 and 0 together. Let's get back to the computer. If we put 2 bits together, no electricity in 2 bits means 0, and electricity in the first bit means 1, electricity in the second bit means 2, and electricity in 2 bits means 3. Grouping some bits together, we can represent not only 2 and 3, but millions and billions and then some images and then videos just like this one. Amazing, isn't it? Rest is easy. Hard disk drives are where bit information is stored without electricity. CPU is where these bits are processed, added and subtracted, etc. And RAM is where the bit information stored for the CPU to access as fast as possible. You need to learn the basics of how a computer and internet works. Once you got them, you will see the logic behind every fancy programming word people put out there. Basics include some mathematics like logic and number bases. For example, why we use decimal in real life? Probably we have 10 fingers, right? So computers use binary because they have 2 states of electricity, exist or not. And also computer architecture, networking, data structures and algorithms are some preliminary courses. And of course you need to learn some programming languages. These are used to give recipes to computer. It may seem a lot, but fear not, since today nearly everything done on computers, I'm sure you can use one of your favorite hobbies and do some programming related to it. You may ask, when learning ends? After learning basics and getting familiar with a programming language, the learning becomes faster. But here is the catch. Programmers actually are not hired to program. They are hired to create recipes, meaning they are expected to solve a problem. Just like a cook doesn't hire to write the recipe in pen and paper, but hired for creating delicious food. The other hindrance is, human beings are amazing at filling gaps. As a result, the documentation or instructions for us are filled with ambiguities. As a programmer, you need to fill those gaps and create a recipe that a thing without a brain can operate. It should be crystal clear. In the process, you'll learn a lot about the problem at hand. If you ever create a task-filling software, I'm sure you will be a tax expert. And this is why programming is hard. You are expected to solve problems, so the learning and pondering never ends. This skill is incredibly valuable and pays a lot. But don't be discouraged. This is a skill which can be learned. No one born as a problem solver. It is learned. With this, I like to give you my first steps to programming documentation as a gift. You can access it via the link in the description. With it, you can create your first program and run it. Thanks for listening, and please comment down below your biggest obstacle when you started to learn programming.